So we have to determine the limiting value of this given function when x approaches 2. So let us do a direct substitution for the value of x. So we have 2 divided by 2 minus 2 minus 4 divided by x squared will be 2 squared, which is 4, minus 2 times 2, which is 4. So we have 2 over 0 minus divided by 0. So that gives us infinity minus infinity, which is an indeterminate form. But we need an indeterminate form of 0 divided by 0. So let us begin by first subtracting 4 over x squared minus 2x from the rational function x over x minus 2. So that will give us x over x minus 2 minus 4 divided by x multiplied by x minus 2. So that will give us, so we take the LCM of the denominator. So we have x times x minus 2. Now we're going to divide this denominator by the denominator of the first rational function, so which is x minus 2. So that leaves us with x. The remainder x that will get multiplied to the numerator. So x times x will be x squared. Similarly for the second rational function, so we divide x over x minus 2 by the denominator x over x times x minus 2. So that leaves us with a value of 1. So 1 multiplied to 4 is going to give us negative 4. So let us now try to find out the limiting value of this rational function. So we have x going to 2, x squared minus 4 divided by x times x minus 2. So that gives us 2 squared, which is 4. So we have 4 minus 4 divided by 2 times 2 minus 2. So we have 0 divided by 2 times 0, which is 0. So we have an indeterminate form of 0 over 0. So now we have to factor out x minus 2 from both the numerator and the denominator. So x squared minus 4 can be rewritten as x squared minus 2 squared divided by x times x minus 2, which gives us limit x going to 2. So we're going to use the identity a squared minus b squared is equals to a minus b times a plus b. So we have x minus 2 times x plus 2 divided by x times x minus 2. So we can cancel out x minus 2 from both the numerator and the denominator, and that leaves us with limit x going to 2, x plus 2 over x. Now we do the direct substitution for the value of x. We have 2 plus 2 divided by 2. So 2 plus 2 will be 4. So 4 divided by 2 will be equals to 2. So this is going to be the limiting value of the given rational function. So we have to determine the limiting value of the given function when x approaches 1. So first we do a direct substitution. So when we do a direct substitution, so that gives us a value of infinity minus infinity, which is an indeterminate form, but we want an indeterminate form of 0 over 0. So let us begin by subtracting x over x cubed minus 1 from the first rational function. So we're going to combine it. For that, first we have to factorize the denominator of the first rational function. So we can factorize by splitting the middle term, and that should give us x plus 2 times x minus 1 minus x divided by, so x cubed minus 1. So we are going to use the identity a cubed minus b cubed is equals to a minus b times a squared plus ab plus b squared. So we have x minus 1 times x squared plus x plus 1. So let's combine the two fractions. So we have limit x going to 1. So the least common multiple of the two denominator will be x minus 1 times x plus 2 times x squared plus x. So here's a 1 missing. X squared plus x plus 1. So we're going to divide this denominator by the denominator of the first rational function. So that would leave us with x squared plus x plus 1, which we multiply with the numerator, leaving us with x squared plus x plus 1. So we have x minus 1 as the common factor, in both the numerator and the denominator. So we already have x1, we have 1 minus x in the numerator, so we are going to multiply it by -1, so that becomes -1 times x minus 1 divided by x minus 1 times x plus 2 times x squared plus x plus 1. So we can factor out the common term, which is x minus 1, from both the numerator and the denominator, and that leaves us with limiting value of x going to 1, -1 divided by x plus 2 times x squared plus x plus 1. Now we're going to do a direct substitution here. Multiply to 1 plus 1 plus 1, which is 3. So this gives us a limiting value of -1 over 9. So here we have to determine the limiting value of the given function when x approaches 3. So let us do a direct substitution here. So we have 1 divided by 3 minus 3 minus 2 divided by 3 squared, which is 9, minus 4 times 3, which is 12, plus 3. That gives us 1 over 0 minus 2 over 0. Now we have an indeterminate form of infinity minus infinity. However, we need an indeterminate form of 0 over 0. So we're going to combine the two rational functions. So we have limit x going to 3, 1 over x minus 3 minus 2. So we are going to factorize x squared minus 4x plus 3, and that will be simply x minus 3 times x minus 1. So let's combine the two rational functions. So we have limit x going to 3. We take a common denominator, so that will be simply the lowest common multiple of both the two denominators. So we'll have x minus 3 times x minus 1. Now we're going to divide this denominator by the denominator of the first rational function, so that leaves us with a remainder of x minus 1, which we multiply to the numerator, giving us x minus 1. Now we have to divide the denominator x minus 3 times x minus 1 by the denominator of the second rational function. That gives us a remainder of 1, which we multiply to the numerator. So we have 2 in the numerator. So that gives us limiting value of x going to 3, x minus 3 divided by x minus 3 times x minus 1. If we do a direct substitution, so we have 3 minus 3 in the numerator, and we also have an x minus 3 in the denominator. So this will give a 0 over 0 form. So that means we have to factor out x minus 3 from both the numerator and the denominator. So that leaves us with a limiting value of x going to 3. We have 1 divided by x minus 1, and we substitute the value of x. So we have 1 over 3 minus 1, which gives us a limiting value of half.